What's going on, YouTube? I talked about this a little bit on Twitch, where I try to live stream once a week. If you want to catch it live, check it out on twitch.tv/ipsec. And that's really the only way to catch it right now, because I'm not doing the whole VOD thing, because I like it to be off the cuff and just a on the moment thing. And when I talk about something cool, I create a new clip or just clip it out of the Twitch stream and put it on YouTube. And I talked a lot about DLL hijacking, which is my favorite way to persist on a box, both as a user or a system. Because there's a lot of various just persistence techniques, like you could go into the startup directory and app data roaming, Microsoft Windows Start Menu Program Startup, drop something here. You could go into the registry. So if I do reg edit, we go, what is it? Current user, software, Microsoft, Windows current version, run. Like we could put keys here to start up. We could do run once, so encode a malware to write itself here upon running, so it stays in this location just in case something's not checking it. We could use a task scheduler. There's a bunch of places we could put persistence. But I really like the DLL hijacking because it's not one of those things you can just look at and know it's malicious. Like all these locations that I said, like task scheduling, registry, startup folders, like those are queryable locations that you can look and then just analyze everything that's starting up. DLL hijacking kind of depends on taking advantage of something else that is running. So to go into it a bit more, let's go and build a sample application, and we're going to do something really cool at the end of this, so don't worry. If this seems simple, just stay tuned until the end. It's still simple, but it's a pretty cool technique that a lot of people don't realize about hijacking things out of Explorer. But I'm just going to compile this. So let's see. x86, W64. Actually, before we compile, I should look at the source code. So we see hello.c. It's just a sample application. It's going to load up ipsec.dll. And then if the DLL was loaded, print DLL found, else print DLL not found. It's a super simple application. And then the DLL we're going to be using for this is just this. When the DLL attaches to a process, it's going to pop up a message box that says, please subscribe to IPSEC and follow him on Twitch, with the title of IPSEC, and it's going to display an error message with an OK button. If this whole message box thing doesn't make sense to you, literally all I did was go to the Microsoft page, look at the message box functions, and then just call the message box. So we can see this is saying if the parameter is null, message box has no owner window. Then the next thing, you can just read this to see what it does. When I get to the type, we had like icon error. And this just says a stop sign appears. And then we also had like MB OK. And this just says the message box has one push button OK. So that's why the message box is going to look like it does. And if I was doing something evil, I would definitely change out this message box to be something else. So now we can go and compile these. So x86, W64, MinGW32, GCC, Win32. This is just my compiler to make executables and DLLs on Windows. So the first one was hello.c. We'll give it the name test.exe. And then we have, was it dll.c? We'll give it the name ipsec.dll. We also have to say -shared to make it a DLL. So now if I run a file against this, we see ipsec.dll is a DLL. And what is the next one? We called it test.exe, and that is a executable. So now we can transfer this over to our Windows box. So I'm just getting my IP address, standing up a web server, and we can download this. So copy. Let's go over here. Let's open up PowerShell. If I can type, there we go, CD desktop. Make this font a little bit bigger for you. And we just want to download the test.exe here first. Test.exe-o, test.exe. So now when I execute it, we have DLL not found. So now we can go over to process monitor, run it as administrator. I think it would ask anyways. And this is just a sysinternal tool. and it's going to show everything every process does. So if I wanted to look at like what, let's see, this MS, my Windows Defender is doing, I can just right click, include it, and I can see everything Defender looks at, right? We just want to look at test.exe. So what I'm going to do is go to filter, and we can change this by double clicking and then just type test.exe. We could have also created it manually by doing these drop boxes, but I like just right clicking here, doing a filter, and then clicking to populate it. So our process name is test.exe. We see nothing here because we weren't running process monitor when this process started. So now I'm going to run it, and we see things start getting populated. So we see the process start, it created a thread, loading ntdll, and if we scroll down, we see it's attempting a create file. It's just trying to get a handle on a file. It's not actually trying to create it. It just wants to get the handle so it can read it. And we see it going from desktop to System32 to system to Windows to desktop again, System32 to WBEM to PowerShell to OpenSSH to this .NET directory to AppData to another .NET directory. So if we can write the DLL to any of these locations, chances are we can do a DLL hijack. And we can also do DLL hijacks if the file exists by just putting it into the current working directory. You can try this later with explorer.exe because it's a really cool one. We'll get into that in probably like 5 to 10 minutes once we finish explaining what we're going to do. So all these directories, how it loads is just the Windows path, right? So if I do echo path, we can see what the path is, and this is the order things get loaded in. The only thing you don't see is the very first piece of a path is the current working directory of that program. I believe it could be the current working directory of the user, but I want to say it's the program. And this becomes important, again, when we do Explorer later. I'm highlighting this because I have seen people that like install Java or Python, and then they want to edit the path to put Python in the path so they don't have to type the full path to Python every time. And they make the mistake of putting it before System32. And when they do that, it enables a lot of bad DLL hijacking, right? This one, we can either write our DLL hijack to our current working directory or this .NET tools because I have Visual Studio installed on this machine. So I'm going to test out both those locations. So right now, it's looking for ipsec.dll and all of those. And I guess one more side tangent. There are DLLs we can never hijack, and those will be called known DLLs. And let's see, I think it's in local machine. And then let's see, system, current control set, control, session profile, I think, or session manager. And then let's see, configuration, known DLLs. So all these DLLs that are here will always be loaded out of System32. You can't really change those. If you can write into this key, then a lot of dangerous things can happen. I actually think it's in a different key. It's not in Session Manager. There's a hidden location where known DLLs are also kept that becomes dangerous, but whole different topic. Just know you can't hijack or proxy these DLLs. So now let's put ipsec.dll in the current working directory and execute test.exe. So I'm going to do my curl, and we're going to do, what do we call it? ipsec.dll, and we'll call it ipsec.dll here. So now I'm going to just clear this, and when we run test.exe, boom, we have the message with the message box that says, please subscribe and follow on Twitch. And when we go down here, let's see, where is ipsec? Create file, success. Now it's going to read and close the file. So success there. Now, let's say we didn't want to put it in the desktop, right? We had a, what was it, a .NET directory here. What was it loading before? Let's just delete this and then run it again and find out exactly where. Actually, we have the path. .NET tools. So I'm going to move ipsec.dll to .NET tools. Does that not exist? Let's see. Users.NET and then a directory called tools. So if I just run this again, DLO not found, right? So cd.net. Let's make dir tools and then move ipsec.dll into this directory. So now we just made this exist, and if you went back in the video and you saw the process monitor, you'd see it tried to load something out of this directory. I'm going to hope we have DLL injection again. So this is why I like the hijack so much, because you can just place that DLL in different spots so it becomes very hard to find. Now, I kept hinting at we're going to do something cool that I don't see a lot of people talking about, and that is hijacking Explorer. So there is one really cool thing. Let's see. Actually, let's just include this again. Change the process monitor, the filter, to be explorer.exe. Okay, let's add it now. So now we're watching everything Explorer does. I'm actually just going to also include the create file filter because that's all we care about. So let's delete it. And then I'm going to, let's task kill /im explorer.exe, force kill it. And now we can actually clear it again. And when we run Explorer, let's do c:\windows explorer.exe. Maybe it's my current working directory, or maybe I left something in from the stream. So let's go cd/windows and just run explorer.exe. So I left something in from the stream. We're already hijacking it. DLL. Let's see. There we go. What? Am I not in an elevated session? This became weird. I may have to reboot this box to easily delete this file. cd.dl/csc/api.dll. There we go. I was not in an elevated session. So you saw what we're doing. We're hijacking that, right? So let's go cd /. So now if I just do c:\windows explorer.exe, we load, and we can see everything it's doing, right? Now, it's loading a lot of things from System32. And we can take pretty much any one of these, like, let's see, include this. I'm just going to use the one I had shown you, because I know this one Explorer doesn't really use. It's called csc/api.dll. It's a generally safe one to use. And we see Explorer is trying to access this file. I thought it was trying to access it out of System32. That's weird. Let's see. I could have swore that file normally exists in System32. I must be in a weird state. Let's see. c:\windows System32. csc/api. Yeah. DLL does exist in System32. My machine's just in a weird state, I believe. But, or maybe Windows applications try to load that. I think I'm going to reboot to see exactly what's happening here, because I could have sworn it would load in more than one location. Oh, I have the path, and I'm only including that path. So let's see. We can do a wildcard here, I think. Maybe I can't. Let's see. Remove. Let's see. Is there a process name? or program name. Let's see, we can just say ends with CSC API.dll. There we go. The downside to doing things somewhat live. So we can see Explorer tries to load it in C:\Windows and then goes to System32. Now, Explorer is a unique binary on Windows in the sense that there's not many exes that exist in this Windows directory. So if I just do find string exe, we got Explorer help pane. I'm 99% sure I created this, but there's not really that many executables that get used. So we're going to hijack the CSC API one because Explorer tries to load it first. So let's go and go to our PowerShell. I'm going to make sure this is an elevated PowerShell. Run as administrator. And then we can just curl, what was this? There we go. So curl ipsec.dll, and we're going to name it cscapi.dll. And before we run this, we're just going to show my Explorer. If I kill it, I can run it again. It tries to load CSC API from Windows, then defaults to System32. So now I'm going to put CSC API into C:\Windows, kill it, and we'll start it again. And we have the please subscribe to IPSEC and follow on Twitch. So we have successfully persisted now inside of, not inside of Explorer.exe, to the side of Explorer.exe. We hijacked that path. And there also is something called DLL proxying. So if you wanted to proxy the function calls, so now let's say Explorer.exe actually needed CSC API to exist. We broke all that functionality because it's no longer loading the correct library. We can do something which is called like a proxy load in a library. So if it calls CSC API, a function out of that, and it doesn't exist into ours, we can proxy it over to the real one so we don't break any functionality. The other thing I love doing about this, because right now we're writing into Windows, so we need administrative permissions. Let me just delete this. Really? DLL CSC API.dll. There we go. So now I am back, and we can look at a program that runs on a lot of computers by default, notably OneDrive. Like, I'm not signed in, it just came here by default, and I want to say it's in a place where users can write. So let's find out exactly where OneDrive exists. I'm going to go into Procmon, or not Procmon. I want to go into Process Explorer, and we will look for OneDrive and see where it exists. It exists in C:\users app data local OneDrive OneDrive.exe. So if I do this, let's go and kill OneDrive. So task kill /im OneDrive.exe /f. OneDrive's not running. I can start it up by double clicking this, and we have it running. Now, we could look at Process Monitor and do that whole thing again, but I'm just going to speed it up and say, I know OneDrive looks for CSC API as well, so we can do the same exact proxy load, so cd into this directory. Let's drop our DLL. We have it here. Double click, and it says, please subscribe and follow on Twitch. Now, if you want to actually weaponize this DLL, you'll have to find that content elsewhere. We do talk about it on a few videos. The ones I would highly recommend, probably search for AV evasion, because that brings up Hackback. In this machine, we did a bunch of AV evasion with Meterpreter loaded in a DLL. The other good resource I would have is probably talking about the DNS threading, because in Resolute, we hijacked something out of the DNS server, and a lot of people didn't thread it, so they hung the DNS server. Remember, like, whenever I executed anything my my DLL hijack there, the application didn't keep going. It just paused until I clicked OK. That's what a lot of people mistakenly did with the DNS exploit in that machine, so I talk about how to thread it to get code running in the background. But hopefully you guys enjoyed this little highlight from the stream. Take care, and I will see you all next time.